So this is the last class, and I don't have more projects to demonstrate, so it's probably going to be pretty short. I just want to talk about this chapter 10, which is somewhat interesting. This management stuff tends to get kind of dry. I've gained more respect for it. In fact, in some of my consulting gigs, what they want out of me primarily is educated white papers explaining the risk, doing risk assessments of technologies they might want to use, like various technologies they're using, and they want me to not only write white papers explaining these, but to back them up with good references to like government agencies and stuff. That turns out to be what they want, and I understand it better than I used to. So these management things that are a little alien to me, because I'm primarily technical, turn out to be more and more important in the real world. So that's what this is. This is data analytics and optimization in operational technology. So a lot of topics, a lot of short ones. All right, so data analytics is when you take data from your sensors, control systems, machinery, and so on, and then you want to figure out something important that you can use, an actionable insight from that. So you want to find trends and anomalies that may help you make decisions and improve your process. So hopefully you can optimize your process, and you can monitor conditions and predict when maintenance is going to be required. So this is data-driven decision-making and continuous improvement. I must say, this is probably a good idea in OT. It gives me kind of a bad emotional response because there's a huge push for this in education. A ton of those stupid forms I mentioned that we have to fill out as a college teacher involve keeping track of what percentage of students succeeded, and then supposedly pretending that when that percentage changes, that means you're changing the course in the right direction, and what changes are you making. But it's done with measurements that are incredibly vague and with numbers that are too small for the statistics to mean anything. And every time you raise that, they say, shut up, shut up, shut up. The law says we will measure it this way. So it basically consists, like a lot of social science and government, of completely fake numbers that mean nothing and then pretending they mean something. But in OT, you have real numbers that mean something, like the percentage of defective products, the pressures, temperatures. This is more like physics and engineering. So you can actually have decisions based on real data that you can measure with some statistical significance. So you can have descriptive analytics that do things like aggregate and visualize historical data, so you have an overview of what's been happening. And then you have diagnostic analytics, where you try to find out what is causing problems. Predictive analytics, where you try to predict the future, and prescriptive analytics, with the ultimate goal of it all, where you make decisions. And this is why computers exist, is because of running the numbers, where you used to do spreadsheets. Spreadsheets used to be something that you did on a blackboard with a hand calculator, and it would take like all day, and you would have like a business decision. Shall we open a new branch office in another city? How much would that cost? How long would it be before it starts turning a profit? Would it ultimately be worth it? And you'd have a whole chart full of month by month and category by category of numbers, and you'd run the numbers, which was calculating this whole chart of numbers, and then you'd erase it and number it again, and then you get the two final numbers, and you decide if it was worth making a decision. And when you could do that in a few seconds on a computer automatically, that was the killer app that made people actually buy and start using computers. So that's just prescriptive analytics. Can you predict what's going to happen enough to make a decision? It would probably take forever. Yeah, that's right. We talked about that. All right. So, and then there's machine learning is, of course, the modern technique hitting everything, where you expose a network of neurons to sample data or real data from the past, and you ask it to predict things, and you train it to make better predictions. So, and so your optimization method is to find the best solution for something, like the best factory process, the best type of equipment to use, and so on. And there's some interesting linear programming is the obvious one, where you have a lot of linear equations expressing, how much the speed of production affects output and how many error rates related to speed or temperature or something. And then something integer programming, which I just looked up trying to understand this. Integer programming is the kind of programming you use to solve problems that are intrinsically discrete, like the traveling salesman problem, where you have a supply chain and you have only, you can either get it from this supplier or that supplier, or you can, build 1 unit or 2, and there's no possibility of building any other number than integers, so you only consider integer values of the variables. And then genetic algorithms. The genetic algorithms I know are ones where you combine previous possible solutions together in a sort of sexual way to mix them together to see which one will survive best. That may be what they're talking about here. I'm not quite sure. Anyway, so real-time analytics is analyzing data as it's generated to respond quickly to changing conditions, and we're all used to this in the IT world from IDS systems that monitor live network traffic and do something immediately when dangerous traffic is detected, like raise an alert or block it at the firewall. So you can have that in OT also. And edge computing is a trend where instead of having one central server far away that does all the work, you have intelligent devices closer to where they're needed. So it lowers latency and, of course, will improve fault tolerance. So you have real-time monitoring, anomaly detection, and predictive maintenance, and therefore an immediate response to events because you're constantly monitoring processes and you react to them right away. And also, then you can have autonomous systems where the local computer might be able to make some decisions without having to ask the home base for questions. And that would, of course, reduce reliance on the cloud. So, your real-time analytics, of course, is reducing latency because the computing device is nearby, and it's therefore more reliable, you would think, because if the centralized cloud infrastructure goes down or is overburdened, it doesn't matter so much if you can make some decisions locally, and that would be more scalable. As you increase the size of your network, you'll also be adding more computing devices to keep up with the load. And therefore, perhaps enhanced security. It may mean that sensitive data stays locally and does not get sent a large distance where it might get stolen, and therefore might save some costs, although I think it would increase some other costs. All right. So process optimization, you're trying to maximize the output, minimize waste, reduce costs, and enhance performance, of course. That's what you want to do, and so there are techniques and tools to do that. Mathematical optimization is the kind you can do really without a computer, where you'd have some kind of equations to describe how much you think failure rates change with temperature and such. This has failed in the past due to lack of enough data. For example, it used to be believed that you had to keep data centers really cold, like 60 degrees, with powerful air conditioners, so people are always getting colds and wearing coats in there. And Google did an experiment and decided it's perfectly fine for your data center to be like 85 or 90 degrees. So at Google, people are just wearing like swimsuits and flip-flops in the data center. And I don't know if that's true, but certainly you save a whole lot of money in air conditioning doing it that way, if you don't really need to cool the devices that much. Anyway, then you can have simulations of your models and statistical analysis, of course, to test hypotheses and consider various options here. And regression, where you try to optimize things by adjusting parameters to get the best result. Lean and Six Sigma are interesting. Lean tries to remove waste. I don't know the details of it. I just looked up Six Sigma, and because I couldn't believe it was what I thought it was, but it is the obvious thing. Sigma is the standard deviation of a normal curve. So 3 sigmas is 99.7% of all the data, and 6 sigma means that the amount of error is only 3 parts per million. That's their goal. Their goal here is to systematically improve your process to where you only have 3 parts per million of defective products being produced, 3 parts per million of failure of the process. So that's pretty amazing, and it reminds me of the gold standard for data center uptime, which is 5 nines, which is essentially the same thing. People promise 5 nines, they shoot for 5 nines availability. It's a myth. Nobody's ever gotten there. Nobody ever gets above 3 in practice. But a lot of people, that's the gold standard. If you could keep your stuff up with 5 nines, 99.999% uptime, that would be considered as good as you can possibly do. And I did hear, by the way, that Hartford Insurance in Texas actually achieved 5 nines for their server farm by overbuilding by a factor of 6, by having 3 physical locations, and by having really a lot of failover processes. And they claim they actually hit 5 nines that way, even though in Texas where they have hurricanes and stuff. Anyway, data mining and machine learning are both ways to dig through your data and try to find opportunities for optimization. All right, so areas to improve is resource allocation, of course. You have so much staff, you have so much electricity, you have so many motors and other products. You figure out how to allocate them correctly. Same thing happens inside computers. You try to allocate your various resources so they're all doing work as efficiently as possible. You try to schedule things that happen at the right time so they will meet customer demand and resource availability. Like there's a lot of difference in the price of electricity at different times of day and things like that. Quality control, of course, to decide how perfect things have to be and how to make sure not too many products are outside your acceptable range. Energy and supply chain optimization is a real big one. Since the pandemic and the failure of the Chinese supply chain that everybody was depending on, now people are rethinking all their plans for supply chains. There used to be a big push for just-in-time supply chains where you didn't have any warehouse full of stuff waiting. Everything came in just in time to use it, which is fine until there's a disruption in a supply chain like COVID, and then suddenly that fails terribly, and now you think maybe you better replan that whole thing and think about possible disruptions in the supply chain and plan to, in fact, have a warehouse full of extra pieces to serve as a buffer there. And of course, safety and compliance are always there. All right, so in predictive maintenance, you try to predict failures before they occur, and you try to combine all these various features to optimize your asset performance. I know in data centers, they think about hard drives this way, how to plan them and how to use them so you get the most good out of them, and it applies to all your other devices. And I suppose you could say it applies to your people too. I often argue with people, a lot of companies in IT, a lot of tech-driven companies around here have people do a lot of overtime. I used to work like 100 hours a week, and I made more money than my boss from all the overtime. And I felt like this is really stupid. This cannot possibly be the most effective way to get the job done. It would be better to just hire more people and have them only work 40 hours a week, I think. But anyway, that's another issue here. What really is the best way to handle people? Another thing they do in tech is every time they're making money, they overhire people, and every time there's a slowdown, they just lay people off like they're disposable, thus destroying employee morale through the company and greatly harming those people. And then a few months later, they just have to hire people back again. And again, I highly question this plan of optimizing your human assets. I really think this isn't the most efficient way to do it, and there are quite a few business people that write papers agreeing with that. But there are traditions, but hopefully these traditions can change. I don't think they're logical. I don't even think they're the best way to make money. Also, inhumane. Anyway, so predictive maintenance in APM, you can do monitoring your conditions to detect deviations from normal operations, hopefully detect when things do fail. You can optimize maintenance activities based on the criticality and failure mode of assets, which makes sense. You would carefully check and maintain the devices that are most critical or most likely to fail, and then you can try to predict, reading useful light and predict the time for failure. Another thing, which is probably not as big in OT as it is in IT, is that the technology keeps improving. So continuing to use old stuff when the new stuff, in fact, is much better and performs much faster and uses less power and such, means that, replacing things before they fail may be the right decision if the new stuff is really much better. So you consider the integration of your various devices and the same stuff you consider for risk analysis, asset criticality, and the impact of failures. All right, so cybersecurity and data privacy are big everywhere. My experience and observation, greater than 35 years old, the overtime will lower the productivity. Well, yeah, I wonder. I think that's why there's this big belief in the Valley that you should only hire young people and expect them to work like 100 hours a week. And there's this myth of the super genius and the 10 times engineer, how the one guy is worth so much more than the others. And I really think we need more data-driven research in this area. I used to be that guy, and I'm less impressed with it as time goes on, especially in the long run at a company. I think you really need reliable, predictable, reproducible activities. Anyway, it's I think, as anybody could tell you, my impression is that the tech companies developed traditions from like immature teenagers that don't have any idea how to run a business, and they still have not really understood the wisdom of old-fashioned business methods, and they still act like a bunch of children. And they need to knock that off and understand the benefits of the old-fashioned businesses like banking and industry, and add the wisdom of their processes and unions and such. I think, anyway. So cybersecurity, of course, if you have a breach, of course, that's bad. You can have safety hazards, financial harm, operational disruption where you can't produce your product. And then there's data privacy. Your employees have data, your customers have data on your network, and so on. So you have to consider this. All right. And so the challenges, of course, the big one is legacy systems. That's the main one. Yeah, that's my feeling. Anyway, about the overtime. So legacy system is the big issue, and legacy processes like Modbus and stuff that really are sort of primitive from IT standards, but they are commonly used in OT, and so you have to converge these two together somehow. Then there's third-party risks. The big one I hear mostly people worrying about now is the supply chain, both the software and hardware supply chain. In fact, I was just talking about this a couple days ago on Pulse Security Podcast. They say you get a device that has old versions of vulnerable stuff in it, and most people won't even provide you with a software bill of materials. So they won't even tell you what version of everything is being used in there. And the same thing applies to the hardware. So it's a problem. And of course, human factors. Your humans may do unwise things, fall for social engineering, have lack of awareness, and so on. And of course, the constantly changing threats, always new attacks, new failures, new opportunities that you might miss. All right. So you do risk assessment and management. You have a defense in-depth approach, so hopefully one control will stop an attack if another control failed to stop it. Security monitoring, incident response, employee education and awareness, patch management, and compliance with regulations. Those are the same things you'll find in every security management process, and they're here too. Most of this stuff is not really new. It's just an application of the same basic principles to a new set of technology. And so data governance is your procedures for handling data assets, and this defines ownership. Somebody is responsible for the data, they own it, and they're supposed to make sure it's handled correctly. Your quality standards, your life cycle management, how do you gather data, how do you store it, and how do you destroy it when you don't need it anymore, and so on. And so you got the differences in technology stacks between the IT and the OT, and interoperability, and the cultural and organizational differences are the big ones I see here. So your strategies, collaboration and communication between OT and IT. In the world of the CISSP, it's mainly about collaboration between technology people and management. You have to learn to communicate respectfully and effectively with management, even though they speak a different language and are thinking about a different aspect of the business. And the same thing's true of OT and IT. These two teams that might naturally resent and oppose each other need to, in fact, work together. And then you have to establish your standards and formats so you can move data back and forth, and your mapping and transformation as needed to move the important data back across through these different networks. Middleware is a big deal in connecting many kinds of devices and systems together. This is one of the first things I ever did when I was on the review board for the talks at DEF CON. There was a talk about a popular piece of Apache middleware that was vulnerable. So I just looked on the internet, and I quickly found a check printing company in Texas that had their middleware product printing checks for a hospital in Canada, and it was completely vulnerable. I could view and even change the data that was passing through with no password at all. And so I figured out who they were and contacted them and told them to put a password on that. But it convinced me that this talk was entirely correct, that there was a lot of that vulnerable middleware out there connecting different systems together. And so we talked about lifecycle management, and therefore you have a governance framework. This is the administration, not the technical stuff, defining who's in charge, what are your processes, what responsibilities do people have. So data ownership and so on, as we talked about. All right. So you got to overcome the complexity of integrating the systems, deal with legacy systems, and of course consider the cybersecurity risks, which is what drove us all here. The standard cybersecurity risks like denial of service, attacks and intrusions where you take over devices. We're all used to that in the world of IT, but now it's happening in the world of OT also. And so you got to have defense in depth, and you have to have an organizational culture where you have to communicate people's responsibilities. And you have to avoid becoming the irritating security guy that gives people unreasonable instructions like ridiculous passwords and restrictions so they can't get their job done. So just go around with you. This is what usually causes lack of buy-in from employees. Somebody pushes a rule on you that doesn't really make sense in your environment and impedes your work too much. And then they'll do something like just prop the door open with a brick so they can go out and smoke because you didn't consider some way of letting the smokers smoke. That sort of thing. They will run around your rules, and then you're worse off than before you put those rules in. So you have data governance frameworks, and you have plans to train and upskill your employees. Got an extra I there. All right. And consider your consultants and partners you might need to bring in for special expertise, and perhaps partnerships with educational institutions. These are the sort of things you might have to do to acquire new talent. Something that happens at other colleges, although I haven't seen it happen too effectively at CTSF, is you're supposed to have an employee, a business management board that comes in and tells you what the local businesses need, and you often adjust your courses to match what they need. Now, we do have this very effective job fair, which is the closest we get to that. But I have taken stuff from the job fair and written courses based on what they want. So it has worked in that regard to some extent. But that's the sort of thing. That's why you'd partner with an educational institution. All right. And so, and then, of course, your vendor and supplier management, communicating with them, having service level agreements, assessing what they're doing are all part of the game there. So let's try a Kahoot, which is the last OT here. And I'll move this down where you can see it. Well, we may have only 2 today. All right. This is the beta test. I appreciate you, a few of you coming here to participate anyway. All right. All right. Which technique identifies the best way to achieve your objectives? Of course, that's optimization. All right. All right, which one reduces waste and variation? That's Lean and Six Sigma. All right. Don't know why the score. Well, I score for just one question there. Okay. Anyway. All right. Anyway. All right. How about multiple controls? So if one fails, another may still work. Yeah, that's defense in depth. All right. Well, there can't be much tension about the winners. All right.